Hi everyone, welcome to my YouTube channel Take Data Engineer. So today we will see the difference between Spark UDF, the traditional UDF and the pandas UDF, and why we are using pandas UDF if we have already the Spark UDF. So there is some performance issue with the Spark UDF if we are handling the big data. So why we are using pandas and what are the features which is not there with the Spark UDF. So we will see in this video. Okay. So, what is UDF basically? UDF is basically user defined functions. So, you are defining a functions, how you are defining a function in Python, Java, Scala, and then you are registering in case of a Spark UDF, and then you are using that. So, to performing any operations, if you want, there is no built-in function available with the Spark or Python. So, simply you are creating a function and then you are registering and then you are using that. So there are certain disadvantage with with the Spark UDF. That's why we are using the pandas UDF. Okay, so let us first see Spark UDF. So Spark UDF, that is the traditional Spark UDF, is a way to extend the Spark built-in functionality. Yeah, so whatever the built-in functionality we have with the Spark, if you wanted to extend some functionality by adding your existing customized function, you can do that by writing your own function. Okay, so Spark UDF can be used in data frame operations to apply transformation to the data. Okay. If you talk about the characteristics, so they have the function signature. So typically how we are defining the Python function, Scala or Java. So in case of Python, you need to register with spark.udf.registered. Okay, and under that you have to register and then you can use it. That we will see later how we are registering in case of Python your UDF. Okay, so first characteristic, the function signature. So similar to that, how we are defining your Scala, Java and Python function, and then you need to register and then you can use on your data frame operations. Okay, then the main important thing is execution. So in case of Spark UDF, that was basically operated row wise. Okay, so whenever apply some UDF on the data. Okay, so basically this operation happen row by row. Okay, so this function is applied to each row independently. Okay, so because of that the performance of a Spark UDF is slow. So because of row operations, what we are facing the serialized and deserialized issue. So because of serialization, deserialization, when you're passing through the UDF and after getting passed is again got deserialized. So because of serialized and deserialized, because of the row wise operations, there is a huge performance overhead. Okay, so because of this performance overhead, we are come up with a new solution, that is pandas UDF or vectorized UDF. So that we will see later. So this was the one of the disadvantage with the Spark UDF, where we are whatever the operations we are doing, that is the row wise operations, and because of serialized overhead. So every time data is serialized and then deserialized when passes through the UDF, passes into the UDF. Okay, and that can leads to a performance overhead. So this was the issue. Because of that we come up with pandas UDF. And third was the performance. So low efficiency, obviously is due to serialized and deserialized. The overhead invoking Python function from JVM at the traditional Spark UDF can be slower compared to pandas UDF, because every time they need to invoke the JVM and then again that is the overhead, that is least optimized. So whenever we are using Spark UDF, so a Spark catalyzed optimizer does not optimize UDF in case of Spark UDF. Okay, now fourth point is the development feature. So flexible, yeah, can be written in Python, Scala, Java, provided flexible to using existing library and the custom image. So whichever language you are writing, either Python, Scala or Java, you can use for that. So there is a flexibility in the case. Okay, and then similar we have integrations also. So work well with the custom Python or Scala or Java code, but may lack of advanced optimized performance. So that integration functionality is there, but there are lack of advanced optimized and performance benefit. Whatever pandas have, it doesn't have. Okay, now come to pandas UDF. Okay, so these are the characteristics of Spark UDF. Now come to the pandas UDF. So pandas UDF, which we already know, that is also called vectorized UDF, which will leverage Apache Spark to perform data performance in more efficient manner. Okay, so whatever code you are writing in Spark by Spark, so you can leverage the pandas UDF and vectorize your UDF. Okay, they are designed to handle large volume of data more efficiently than traditional UDF by processing data in batch rather than row by row. So what was the disadvantage? So there was only disadvantage of the Spark UDF, that performance are doing row by row. Because of that, we have serialized overhead, serialized deserialized overhead. So now this solution we got in Spark pandas UDF. So pandas UDF handle the large volume of data more efficiently than traditional UDF by processing the data in batch or column format. So whenever you are writing UDF and performing, so every column or every batch get processed instead of row by row. So there is no serialized deserialized overhead in case of pandas UDF. Okay, now again we'll see characteristics. So function signature. So this also have the panda functions. You define a function operation on a pandas data frame or series and then register in the pandas UDF. So that way you can do that. Batch processing. So these functions basically works on the batch or column rather than individual rows. Okay, then execution. So this basically perform the vectorized operation. So operations are performed on whole column or batch of data. Okay, so that is not row by row. So that is the vectorized operations they have. Because of this have this more advantage. Then arrow integration. So uses Apache's arrow for in memory column data representation, which basically reduce the serialized and deserialized overhead. Okay, so now come to performance. So obviously because of all this functionality they have, data is processed in batches and there is reduced overhead from serialization. So pandas UDF can more faster than traditional Spark UDF. Then optimize executions. So Spark can optimize the executions of pandas UDF better. Okay, especially when working with a large data set. So with a smaller data set you don't find much difference in the execution. But yeah, obviously if you are working with a huge data set, then there is a huge I can say better performance you can find in case of pandas UDF. Development is also easy. Allow you to use pandas like syntax and operation, making it easier to perform complex data manipulations. Then integrations also particularly useful when you need to perform operation that are easy to express with the pandas but more efficient or complex with the traditional UDF. Okay, so now we can see the summary. So Spark UDF is good for custom logic and function, not easily expressible in SQL or data frame operations, slower due to row wise processing and overhead of serialization. So this is the summary of Spark UDF. So pandas UDF we have ideal for vectorized operation leveraging pandas syntax, and ideal for high volume of data. Okay, so now see let us see these things pandas UDF and Spark UDF with example. So suppose we have a data frame with column of integer. So suppose we have a series 1 2 3 4 5 6 and I wanted to perform square of the number. Okay, then what I will do, I will create a Spark session. I'll import whatever the things. I'll create a session with give UDF example. Then data is like 1 2 3 4 5 and I wanted to create a functions which will basically multiply the same number like a square of a number. Okay, so this is our data frame as a number. You'll see 1 2 3 4 5. Now if you'll see the traditional Spark UDF, so first we need to define and register. So whatever the import library we have, SQL function UDF, PySpark to SQL functions, we are importing the UDF and data type. Then we will define a function called define square number n. If you are passing, then what we are returning n into n, the same number we are multiplying 2 times, that is square of number. Then we are registering the UDF square. UDF equals to UDF square number and what is the return type, integer. Yeah, so after when data is getting passed from the UDF, what is the return type of UDF is the integer type. Okay, then apply the UDF to the data frame. So df with column, we are creating a column called a square and then we are passing the square UDF square UDF. This is the registered one. So square UDF as a data UDF on the column called number. So after passing, if you'll see the result, df the square, so is number and then their square is coming from here, dear with column df dot with column. Okay, so this one is coming squared, and each number is getting passed, and then their corresponding squared column is 1 4 9 16 25. Similar you can see in pandas udf how we are doing. So if you'll see the pandas udf also, from pi square dot functions import pandas udf, then pi square sql dot type import integer type. Similar we have to register like at the rate pandas udf, what is the return type, integer type, and we are passing the series spark square pandas udf and return series into series. Then we are again creating a column called pandas squared, and then square pandas udf equals column, we are passing column as a number, and here also we are seeing number and squared, and the summary number and squared. Okay, so the basic summary for this is traditional udf have row wise operations, they have serialized deserialized overhead, and that issue got reduced in case of pandas udf because of vectorized nature, batch processing nature, or columnar processing nature. Because of that, pandas udf are more efficient, they are used more when there is a huge volume of data. If your job have performance issue with that, so you try pandas udf instead of spark udf. Okay, thank you, thanks for watching.